Welcome, this is the 3.6 homework solution for the Ready, Set, Go part. The Ready part, it says find the point of intersection where f of x equals to g of x. Before, we mostly deal with it in the graph, but now we are dealing with it in terms of equations, okay? So we have to set equal to each other, do some algebra to solve for the variable. So f of x equals to g of x. So I set the equation equal to each other. Again, basic algebra, we want to move the smallest variable. So I'm going to add 5x to both sides. Simplify becomes 12 equals to 3x minus 3. Move the smallest constant. So I add 3 to both sides. Get the coefficient to 1, so I divide by 3 to both sides. I get x equals to 5. So the intersection between f of x and g of x in this case would be at x equals to 5. So if you put your input in for 5, x equals to 5, you get the intersection. Okay? Do you want to see that? Would that make more sense if we put that in decimals? Alright, let's put this in decimals. Okay. So let's define f of x is equal to negative 5x plus 12. Let's define g of x as negative 2x equals negative 2x minus 3. And let's define where f of x is equal to g of x. Okay, that should be at 5. So let's look at it. Right, both of them are graph. Right, and boom, at 5, do you see? They intersect. Valid. So our answer there is valid. Okay. All right, let's look at that one. Next one. 1 half x plus 2 is equal to 2x minus 7. Right. So I have to get rid of that denominator of 2, so I multiply everything by 2. X plus 4 equals 4x minus 14. Minus 4 to both sides and add the 14. Get the constant to 1, so I divide by 3. X equals to 6. Again, I want to test this one out, okay? So f of x was my 1 half x plus 2. And my g of x is 2x minus 7. Did they intersect here as x equals to 6? Yes, they do intersect here at x equals to 6. So that is a valid answer. See, this is a good way of using decimals to check your answer, okay? I show it for you for 1 and 2. Again, you can check using decimals if you like, but moving forward, I'm just going to display the answer, okay? Said equal to each other. I try to get the denominator 1, so I multiply 3 to both sides. Okay, then I add 2x to both sides because I want to combine the variables. Minus 21 to both sides because I'm trying to combine the constants. Here it's still negative 1, so I have to divide by negative, so x equals to positive 6. Same process for 4. Subtract x, then add 6, then divide by negative 2. 0 divided by any number is still 0, so x equals to 0 in that case. Alright, let's look at the set. Okay, so here they asked us for the multiple points, right? Here's the graph. Where is f of 4? F of 4 is equal to 1, so let me show you, right? That's the input of 4. The output here was 1. The input here was negative 4. The output at negative 4 was at 7. When was the output equal to 4? The output was equal to 4 when the input was 0. When was the output equal to 7? The output was equal to 7 when the input was negative 4. Okay? Right? So that's what I display to be proof of how I got those answers for the set part. Alright, same thing here. This looks like it's exponential. If I have your input of negative 1, so the negative 1 looks like it is right here. Negative 1. It is at 2, so g of negative 1 equals to negative 2. So your input of negative 1 gets you the output of negative 2. Your input of -3 gets you the output of -7. Your output of -4 right here, do you see that? Is from having an input of -2. Your output of -1 is because of your input of 0. Let's look at 7. A little clustered here, so just listen up. When you have your input of 0 for H, your output is -5. Right? 0, -5. When your input is 3, your output is roughly around 3.5-ish right there. When your output is 1, so it looks like it's 1, your input here is roughly around 4. So if you plug in x equals to 4, your output will be equal to 1. Right? That's what that dot means here. When is your output equal to -2? -2 is right here, and that is when you have your input of x equals to 2. Let's look at 8. Ooh, a bunch of discrete values here. D equals to -5. D of -5, or your input is -5. Looks like at -5 it equals with an output of 1. Okay, so this should be a 1. When your input D equals to 4, looks like your output here is 2. Good. When is your output equal to 3? Output equal to 3. 1, 2, 3, right? When your input here is, what is that? 1, 2, 3. Oh, it's also 3. When your input is 3, your output is also 3. Right here as well. Looks like your input is 1, 2, around 2-ish something. Your output would also be 3. Okay, be very careful. When is d of x equals to 0? D of x is equal to 0 at this point, right? So it happens at x equals to -6. It happens at x equals to 0, x equals to 1, and x equals to 5. They all have the output here of 0. Alright, next, for your situation, create a function using the given information to find and interpret the solution. Alright, Frank collects data on the number of feet she walks each second and wrote down the following rules to model her walking rate. dt is equal to 4t. 4 is probably her rate of change, her slope. D just probably stands for distance. T is for time. So distance is a function of time. Her rate here is 4. What is Fran looking for when she writes d equals to 12? That means 12 seconds because that is your input. And your output would be, so plug in your 12 in t. 12 times 4 is 48. So when it is 12 seconds, she walked 48 feet. Next, when d of t equals to 100, that is, the distance is already 100. When the distance is already 100, how do you solve for your time? So remember, this is equal to 4t. So 100 is equal to 4t. Divide by 4, you get t equals to 25. So at 25 seconds, you walked 100 feet. How can this function rule be used to indicate a times of 6 seconds was walked? 6 seconds was walked refers to 16 seconds. T was 16, so substitute t is equal to 16. Do that multiplication, so it equals to 64. So she walked a total of 64 feet at 16 seconds. D. How can the function rule be used to indicate the distance of 200 feet walk? Again, you said equal to 200 equals to 4t. Solve for t. T is equal to 50. So at 50 seconds, Franny walked a total of 200 feet. Alright, was that it? Okay, let's look at number 10 now. Mr. Moodbank has developed a population growth model for the rodent in the field in his house. He believes they start the spring. The population can be modeled based on the number of weeks within the function p of t equals to 2 to the power of t. So the starting value is 8. Wow, that's interesting. This is the zero term equation because there's no minus here. The base rate is 2. Okay, so it's growing, right? It's not decaying. If it's less than 1, it would be decaying, but here it's greater than 1, so it's growing, right? They're asking us to find all these three values. Okay, so I show the calculation here. P of t equals to 128, so that is a substitution of 128. Solve for t. I get, after I divide 8, I get 16 equals to 2t. You would have to guess and check. T would be equal to 4. So 2 times 2 times 2 times 2 will get you 16. Alright, what happens when you fall into this case? So P of 4, 4 goes in for the T. 2 to the power 4 times 8 is 128. C, P of 10. So the T gets your 10. So it's 8 times 2 to the 10th power. Okay. D, find the numbers a week it would take the population to be 20,000. So I said equal to 20,000. Okay, equals to 8 times 2 to the power t. Divide by 8, I get 2,500. I say I'll have 2. So here, the only way I know how to solve for the exponent, besides guess and checking, is to use your log. So log base 2, because that's your base number. And it equals to, so log base 2 of 2,500 is t is equal to roughly around 11.289. So around at 11 weeks, she gets roughly 20,000 rodents in total. Right, so that's why E asks, in a year with 16 weeks of summer, how many rodents would be expected by the end of the summer? 16 weeks. So put in t equals to 16. Then you solve for it, and it is around 500,000, 524,288 at week 16. Alright, it says what are some factors that can change the actual results? So here, there is a chance that your house does not get 524,288 rodents by your 16 week. The reason why is because like any resource, they have to grow, they have to reproduce. So one, if there's not enough room, they cannot reproduce, so they cannot grow, as well as resources. So if there isn't enough food, they cannot grow. Alright, so those are the two limiting factors. Okay. Alright, let's go to the go part now. Alright, so for each graph, give private description of the function. Be sure, right? So you're going to tell us the decreasing, increasing, min, max, domain, and range. Okay. Alright. So I'm just going to display it for you here. The domain, it is closed at 0 and it goes all the way to 13. The range is its smallest y value, which is 1, goes all the way up to the 11 value there. The max would be here at 10, 11. Minimum here would be at 3, 1. It's decreasing here, and here it is going up from 3 all the way up to 10. Right? That's a positive, that's an increase, and that's also an increase as well. Okay. This one, the domain would be negative infinity because it goes all the way to the left, right? And it stops here at 30. So negative infinity all the way to 30 would be your domain. Your x value, your input, your domain. Your range is your smallest y. Your smallest y looks like it's 24. It's closed, so it includes 24. It goes all the way up there to 0. It's not really touch 0. So we would say it is open at 0. Your max is y equals to 0. Your min would be right here at 20, 24. If you read this from left to right, it looks like it is decreasing. So it is decreasing from negative infinity all the way to 30. And it's not increasing, so we put none for increasing. Here's this one. The domain is negative infinity all the way to positive infinity because it is a line based on the ends. Range, again, same thing. It goes from negative infinity all the way to positive infinity. What is the max? In this picture, it looks like it is at 7. So y equals to 7. Okay, right here, right there. That's y equals to 7. right? When y equals to 7, that is the max, right? That is with your input of 9, but that is just based on the picture, right? The min here is at -2, and that's when we plug in a -6 for the x, right? But it goes on forever, so there might be other maxes and mins, okay? Never decreases, and it's increasing all the way from -infinity to +infinity. Okay, we can't really say what happens without looking at the equation. Something might happen in the long term, but based on just looking at it right here, we could determine its relative maximum and relative minimum. Alright, so there you go. That's it. That was all your homework solution for 3.6.